So this first question talks about a car company that introduces a new car for which the number of cars sold is S, and then they give us a function. So time they're telling us is in months, and then S would be in the number of cars. So first it says find the value of S prime of 2.5, and then using correct units, explain what this means. Now this is a calculator question, so it's actually, you really don't need to show any work on these at all, which is super nice. So what we can do here is, I'm gonna just clear out my calculator screen just so it's nice and fresh. You don't have to do this, but if you want to, actions, clear history will kind of just erase everything on your screen, which is kind of nice. So we're going to take the derivative, and you can do this in one step. I'll show it doing it in one step or in two steps. But we'll take the derivative with x, and I'm going to use x instead of t, but if you want to use t, t would work as well for this one. I like to use x just in case I graph them. So 300, and then parentheses, we had 5 minus, and then 9 over, I think it was t plus 2. Yeah, 9 over t plus 2. And instead of t, like I said, I'm going to use x. But if you wanted to use t, then just make sure both, right here, dt, and then this would be a t. And then on the outside, I'm going to show this in one step. So in one step, this is the derivative. But then outside, we can say we can say x equals 2.5. So this would be in one step. And then we get 133.3 repeating. Now, if we had wanted to do in two steps, you could do it without the at. This is the formula for the derivative. So now this would be the formula for s prime of x. And then we could then plug in that one at x equals 2.5. So that works as well. Or you could graph that one and use the trace. That works as well. But either way, you should get 133.3 repeating. So what we're going to do is we're going to say s prime of 2.5 is equal to 133.3 repeating. We're going to go out to 4 decimals. And then using correct units, explain what this value represents. So what we'll say is that basically we can say something like s prime of 2.5 represents the change, or the rate, we could say the rate of change, really. The rate of change of, so anytime we do a derivative, it's always the rate of change, or the rate of, and then whatever we have. So the rate of change of the number of cars sold. And we want our units. So in cars per month at time equals 2.5 months. Now, would this be an increase or a decrease in cars sold? This would be an increase in cars sold, right? So there are 133.3 repeating more cars sold, per month at 2.5 months. But our key here to kind of look at and maybe make kind of a sentence starter for you to start practicing is, as soon as you have a derivative, that's always the rate of something. Then it's the rate of whatever they told us it was, and you always need in the units and then at the time. Now, how do I figure out my units? Well, my units are just, they told us S was cars, so we know S prime will be cars per month. And then if we had to do a derivative again, like S double prime would have been cars per month squared, right? We just keep adding on it per time. So that's kind of how that works. Okay, next one, find the average rate of change of the cars sold over the first 12 months. So our average rate of change formula is equal to S of 12. Now the first 12 months, they just gave us 12, but remember, this always has two, S of B and S of A. So the first 12 months would have been from 0 to 12. So S of 12 minus S of 0 over 12 minus 0. Now we're not going to plug these into the derivative. We're going to plug these into the original. So this will become, right, we'll kind of do into the original would have been this one here. So again, on our calculator, if we hold down the shift key and start pressing left, it'll highlight this guy for us. That's the original formula. So I want to do that one. at time 12 and at time 0. So at x equals 12. And I'm going to do control enter to just get a decimal. I like those better for free response. And at x equals 0. So 1307.1429 minus 150 divided by 12 minus 0. Make sure that you keep your order the same, right? If I put 12 first, I need to put s of 12 first. If I put 0 first, I need to put s of 0 first. So this will then give us, we'll just kind of do that math out. So we'll say we want to do control divide, right? And we can just come up here and grab this. You can come up here and hit enter and it'll bring it right down. That way you don't have to retype it. Come up here and hit enter, bring it down over 12 minus 0. You just put 12 if you want to. And we get 96.4286. 96.4286. And I'll do units. I probably should have done units here too. The units up here were cars per month. And again, for average rate of change, we're going to have the same units. Cars per month. I talked about this in class, but if you're not sure about your units, a good strategy is this, right? And rate of change is always a derivative. So it'd match with average rate of changes there. But another strategy could be to kind of think, okay, what were my units for S of 12? Well, S is in cars. So my units for S were in cars. And then 12 minus 0, those are my times, those are my months. So cars per month. So that's another way to get those units. Now, it then said to explain what this value represents in the context of this problem. So what we would say is that this is the average rate of change. So we can say that the average rate of change in cars per month, right, our units, is 96.4286. And you could even add in, cars per month again if you really want to, for the first 12 months. So what is it? It's the average rate of change. Oh, wait. The average rate of change for what? I did mess that up. So we want to remember the average rate of change of the number of cars sold. And then in cars per month. Okay, so remember, it's always the rate of, and then whatever we had in the question, the number of cars sold. So I forgot that part. So the rate of the number of cars being sold, that's one thing. Our units is another thing to look out for. And the time is the third thing to look out for. Okay, next one. Is it possible for the value of C? So as soon as I see that word, is it possible? I'm thinking IVT, I'm thinking rolls, or I'm thinking MVT. So is it possible that a value of C for 0 less than 12 less than, 0 less than or equal to C less than or equal to 12 exists such that S prime of C, as soon as I see S prime, I can kind of get rid of IVT, is equal to the average rate of change. So that's MVT, right? S prime of 0 would have been rolls. So the S prime of C, that's the instantaneous rate of change, is equal to the average rate of change. Give your reason and then find the value if it does exist. So if it does exist, they want us to then find it. So first, is it possible? Well, MVT is continuous and differentiable. Those were our conditions. So let's kind of go back up here and see, did they tell us about continuous or differentiable? They didn't, but we can kind of see where would this not work. So you can kind of see that we would not be able to plug in -2. So basically, t equals negative, t cannot equal to -2. But we're saying between 0 and 12, so we could say that, S is continuous for 0 to 12. And we did take the derivative, so let's look at that, right? We took the derivative up above, and we got that the derivative was, in this first line, 2700 over x plus 2 squared. So our derivative also can't be negative 2. I'm just going to write that, though, just so we have it. So we're going to just write in s prime of t, right? I'm going to change the x's back to t's, was 2700 over t plus 2 squared. So we can see that also t can't be negative 2 for that. So s is continuous for 0 to 12 and differentiable for 0 to 12. So MVT applies. So MVT applies. Therefore, it is possible. Not only is it possible, it's actually guaranteed. We might even change that word possible to guaranteed if we want to. That a value c exists for 0 less than or equal to c less than or equal to 12, such that s prime of c is equal to the average rate of change. So we're just kind of rewording it right here. Or rewriting it, I should say. And I'm going to just add in again by MVT. Really, they're going to look for the words MVT once, but the more you have it, the better. So by MVT. Now we want to then go ahead and solve it. So how do we solve it? We need to set the derivative, right? We need to set s prime of c equal to s of 12 minus s of 0 over 12 minus 0 equal to the average rate of change. Now, we've already done a lot of this work in the previous steps. So we've already taken the derivative. So we can just plug in 2700 over. Now you could say t plus 2 squared. I'm going to put c plus 2 squared because we're solving for c. But if you put t, if you put x, you're not going to get it marked wrong. And we need to set this equal to s of 12 minus s of 0 over 12 minus 0. And we already did this up in part B. We did that. We got 96.4286. And this, you need to write this step down. Like this needs to be written down. So you need to write that. But you don't have to show any work because you have your calculator. So on your calculator, then you just solve it. So how do we solve it? We use our solve button. So we're going to go to menu, algebra, solve. If we ever get there. And then we're going to take the 2700 over x plus 2. You could change the x to a c if you want to. I'm not going to. And we're going to equal it to, and again, you could retype it, but if I know it's right there, if I just go up and I hit enter, it'll bring it right down. Now, normally we had done equals to 0, but this one we're equaling it to 96.4. And then we're going to do comma x. If I had changed it to a c, we'll do comma c. Now, I can hit enter here, and you'll get some answers. But if we have an interval, I always like to add at the end, after the parentheses, I like to add my interval. Just to make sure it's only giving me values from 0, less than x, less than 12. And so we get 3.2915. So 3.2915. So then that will be our answer. And so we'll say C equals 3.295. 2915. That was my fault. 2915, right? Out to 4 decimals. And then this was a time, so it's in months. So, if I add the word months, that's great. So there's that one. And this is all the work you need to show, right? You don't need to show any more steps. They know that you have a calculator and you're solving it on your calculator. Now, this last question is non-calculator, so we're going to get rid of our calculator for this one. And they give us a table, and they tell us that f and g are differentiable. So because they are differentiable, we also know that they're continuous, right? Remember, differentiability implies continuity. So that's going to tell us, right, because they told us that, we know that IVT is going to apply, MVT is going to apply, and Rolls is going to apply. They also tell us that G is strictly increasing. Let's kind of remember that. That might help us out somewhere. So we know G is strictly increasing. What does that tell us? That means that G prime of X will always be greater than 0. Okay, and then the table above gives us the values for the original functions and for the derivatives. They also give us h of x is equal to f of g of x minus 6. So they want us to first find the equation of the line tangent to x equals 3 for h. So x1 is going to be 3. If you're not good at these, try pausing this video and just kind of plugging these in just to try them. On your own, it's good practice. So h of 3 would equal f of g of 3 minus 6. This is called composition of functions. We need to practice these, okay? So f of g of 3, we're going to first plug in g of 3, right? G of 3 is 4. So this will become f of 4 minus 6, right? First we plugged in g of 3 and we got 4. Then f of 4 is negative 1. So negative 1 minus 6, that's going to be negative 7. Next, we're going to then do m. To do m, we have to plug it into the derivative. Well, before we can plug into the derivative, we need to take the derivative. So h prime of x equals, now, this is chain rule, right? F of something. So f prime of that box and times the derivative of the box, g prime of x. Then the minus 6 part goes away because the derivative of 6 is 0. So for m, right, m we're going to get as h prime of 3. We're going to need to plug into there. So f prime of g of 3 times g prime of 3, right? Anywhere we see an x, we're putting in 3. So g prime of 3, sorry, g of 3 we knew was 4. It's going to be f prime of 4 times g prime of 3. So f prime of 4 is 3, and g prime of 3, g prime of 3, not 4, is 2. So this is 3 times 2, and we'll get 6. So we need to write the equation of the tangent line. So I'll kind of write it out here. Y minus negative 7, that's going to turn to y plus 7, equals 6 times x minus 3. B says find the rate of change of h for the interval from 1 to 3. And this is actually my fault when I was copying some of this stuff. This should say find the average rate of change. They'll never say find the rate, for 2, but without average. So that should have said find the average rate of change between 1 and 3. So how do we get the formula for average rate of change? Well, average rate of change would be h of 3 minus h of 1 divided by 3 minus 1. Right on the AP test, they would have absolutely put the word average there. So I'm going to do these kind of off to the side, h of 3. Now, we actually already did h of 3, right? We got negative 7. Then we need to do h of 1. So h of 1 is going to be f of g of 1 minus 6. So g of 1 is 2. So this will be f of 2 minus 6. And f of 2 is 9. So 9 minus 6 gives us 3. So then h of 3 was, we said, negative 7 minus 3 over 3 minus 1 is 2. That's negative 10 over 2, or negative 5. So our average rate of change between 1 and 3 is negative 5. Next, explain why there must be a value of r for 1 less than r less than 3, such that h of r equals 2. So explain why there must be. Immediately we're thinking IVT, we're thinking roles, or we're thinking MVT. And we want to look at what do they ask us. They want for h of r equal to negative 2. Not h prime, but h of r. When we see h of r, we're thinking IVT, right? So h of 3 on IVT, we want to look at our endpoints. So h of 1, we knew was equal to 3. And h of 3, we knew was equal to negative 7. So IVT is basically saying, is negative 2 in between 3 and negative 7? Yes, it is. So what we can kind of say is, first we need to show that IVT is going to apply. So we'll say that something like h of x is differentiable. So it's also continuous. Therefore, IVT applies. We need to kind of write that. So now with IVT, right? We can say that h of 3, right, that -7 is less than -2, which is less than h of 1. If you want to add in like the -3 and the 7, you could. You could say like -7 is less than -2 is less than 3, and then you could put equals to h of 1 on this one and equals to h of 3 on that one. So you could have written it like that also. Either way, that works. So -2 is in between there. So, by IVT, there must be an h of r equal to -2, right? Because -2 is in between those endpoints. So that's what IVT is saying. So make sure you practice writing that. It's kind of complicated to write it. But as long as basically you're showing that -2 was in between those two endpoints, and you stated that IVT works because it's continuous, and then you say, yes, there must be that value. Okay, then D, again, explain why there is a value. So immediately we're thinking IVT, we're thinking MVT, or we're thinking roles. Now, we're probably not thinking IVT just because that was part C, but I'm going to just list it. Such that H prime of C equals -5. So as soon as I see H prime, I'm thinking either MVT or roles. And because it's not equal to 0, it's equal to a number, we're thinking MVT. So what are our conditions for MVT? It has to be differentiable and also continuous. Well, we know h of x is differentiable. The question told us that. So if h of x is differentiable, then it's also continuous. So MVT applies. Therefore, we know that h prime of c has to equal, right, h of 3 minus h of 1 over 3 minus 1 by MVT. And we already plugged that in. We got -5, so h prime of c equals -5, for some, c1 less than c less than 3. I'm just going to kind of repeat it by MVT. Right, they didn't ask us to solve for it. We can't really with a table. We would need an equation, but that works there. So again, go ahead and rewatch some of this if you need to, or practice this. But it's not a big part of the AP test, but it's definitely a part of the AP test, is using these theorems, especially IVT, MVT, and roles, and looking out for those keywords. Why there must be, is there, is it possible? Those kind of keywords are telling us that we're going to use one of these 3 theorems.